Welcome to the another session of air quality analysis. So far we have learnt what is air pollution, how the air pollutants exist and what are their sources, and how vehicular pollution, especially in India, and also from the industries, how the air pollutants are emitted into the atmosphere, how long they are staying in the atmosphere, in the air, what we are breathing, and also the adverse health impacts on human beings as well as the vegetation we have seen. So now we have to see some of the methods that can be controlled the air quality analysis. Today we are going to discuss about some of the methods. That is, the first method is the gravimetric method. That is, high volume and low volume air samplers are used traditionally to sample air for particulate and gaseous pollutants. So in this method it captures more than 1500 cubic meters of air for 24 hours period, and the low volume air samplers are also used to draw about 24 cubic meters of air. A pre-weighed filter paper traps particulate matter as the air passes through that instrument. So if you look into that diagram, you can understand that how the air sampler looks like. After the sampling, the filter is reweighed, and the difference in filter weight is the particulate matter mass. So that indicates the particulate matter, that is a mass of that particulate matter. Afterwards, the particulate matter that is retained on the filter, that is analyzed to determine the concentration of different pollutants like metals and organic pollutants like polyaromatic hydrocarbons or polychlorinated biphenyls, like that. Especially in our country, high volume air samplers, that is manufactured by the Envirotech New Delhi, is mainly used for the air quality impact assessment studies. We have just, if you see the diagram of that one, you will identify that. Ambient air that enters the sampler through an omnidirectional inlet that is present inside, which is designed to provide a clean aerodynamic cut point for particles that are greater than 10 millimicrons. The particles in the air stream that is finer than 10 millimicrons that proceed to a second impactor, that also you can see, that has an aerodynamic cut point at 2.5. So the air sample and fine particles that is exciting from the PM 2.5 impactor, which are passed through a 47 millimeter diameter of PTFE filters, you will also see in the diagram, that retain the particulate matter of 2.5. So this system, that is the Envirotech APM 550 model, just I am explaining that allows removal of the PM 2.5 impactor from the sample stream. So the sampling rate of the system was, normally we will keep it as a constant at 1 cubic meter, and also with a suitable critical, we can say that the orifice of 24 hours, or we can see the critical time duration of 24 hours. So sometimes the cascade impactors are also there. That is another version where the aerosol sample that passes through a sequence of stages. So in each stage, an air jet that is having the aerosol, combination of the aerosol that reaches the impacting plate, and also the particles larger than the cutoff diameter for the stage that are collected. That means we have already given 10 PM10 particle size as well as PM 2.5. So those particles will be collected on the this plate. So the smaller particles that follow the gas flow, which is surrounded by the collection plate and also collected in the next stage. So in that the orifices are smaller and also have the conditions for the greater air speed. So this process continues until smaller particles are removed in the filter, that is a after filter. So the other method other than the gravitational method is the optical methods. So in these optical methods, there are aerosol particles, they are by the lit by at night be light beam, and also or otherwise it will comes from the irradiate this light in all directions, that is a scattering mechanism, normally we can say that. So part of this light is simultaneously transformed in another energy forms, that is normally we can call it as an absorption mechanism, and also the extinction of that light, that is the emitting light, that can be calculated by the addition of scattering and absorption. So the optical instruments that are used for the measuring particle concentration in real time is based in the principles of scattering, absorption and the light emitting. So the scattering photometer is another type, if you will see in the diagram. In this, the scattering light is measured by employing a photometer detector. So among the scattering photometers, respirable aerosol monitor, that is RAM, is a kind of instrument in which the aerosol was aspirated with the help of a pump. Then it will pass through a cyclone that separated the respirable aerosol fraction. So the aerosol that enters the optical sensor zone, where the infrared light that is scattered in the angle of 45 degrees to 90 degrees, and the aerosol was detected by a photodiode. So the condensation particle counter is also there. So it is also classified as light scattering counters. So these counters are employed to measure the concentration of small particles. So these particles do not scatter light sufficiently in a way that conventional optical counters, what we have seen, cannot detect this scattering. Then spot meters are also the equipments, if you can see the diagram. This is also known as reflectometers, or we can also call them as a smoke filter meters. So in this, the concentration of particles that is obtained by filtering the exhaust gas in a paper filter, and recording of the ratio between the light reflected by the exposed spot and also not exposed spot. So exposed and then non-exposed spot. So here it is a athelometer are the instruments which is used to determine the concentrations. And the other method also we can use to detect this one, that is the microbalance method. When the particles are collected over the surface of an oscillatory microbalance element, if you will see the diagram, those microbalances which are used for the alteration of the resonance frequency to determine the particulate matter. So there are two main measurement instruments which are used in the microbalance method. One is the tapered element oscillation microbalance, that is a TEOM, and also the quartz crystal microbalance QCM, and the mobility analyzer. So among the mobility analyzers, the electrical aerosol analyzer, that is EAA, is the oldest mobility analyzer which we are using, and the DMA as the most recent model. So here in DMA, it is used as a bipolar diffusion charging to bestow a well defined charge distribution in the aerosol. After loading, the particles are inserted into the electrostatic classifier, that allowing particle passage in a narrow range of electrical mobility. So the classified particles are measured by an electrometer, or we can call it as a CPC. So that is a differential mobility spectrometers are also there. So out of these spectrometers which are based on the particle mobility, the most known are the differential mobility spectrometers, what we have seen, the DMS, and the fast mobility particle sizer, that is a FMPS, scanning mobility particle sizer, that is SMPS, and also twin differential mobility particle sizes, that is TDMPS. They are also widely used. But in that, SMPS is an analytical instrument that measures the size and number concentration of the aerosol particles with the diameters from the 2.5 nanometers to 1000. So this method is based on the physical principles, that the ability of a particle to traverse an electric field, that is the electrical mobility, what I would like to tell. In a differential mobility analyzer, that is a DMA, an electric field is created, and then the airborne particles that drift in the DMA according to their electrical mobility, And also the aerodynamic particle sizer, that is a particle size distribution, PSD normally we can call it as, and aerosol mass spectrometer, AMS, are the equipment which are used to measure aerodynamic size. If you will see the diagram, you can also better understood this one. APS is a spectrometer in which I think you must have understood well so far. APS is a spectrometer in which working principle is mainly based on the acceleration of aerosol sample that flow through an accelerating orifice. So, the particle aerodynamic size that determines its acceleration rate. Larger the particle size that accelerates slowly, obviously we know because of the density due to a larger inertia. At the nozzle, the exit the particle cross each other through two laser beams partially overlapped in the detection area. So, the light is scattered when each particle passes through overlapped beams. One is elliptical mirror placed 90 degrees in the relation to the laser beam axis that collects and concentrates the light over an avalanche, that is a photo detector. And the next, this APS converts light pulses into electrical pulses. So, there are some methods are also there for that like gaseous pollutants like NOx or otherwise SOx. To analyze the impacts of oxides of nitrogen and sulfur dioxide concentration, high volume air samplers are required. They are used to where the air is passed through the absorbent solutions that is kept in impinger tubes seated in the gas sampling assembly. So, the solutions are kept cool by cold water bath. The absorbent solution to collect NOx or the nitrogen dioxide is 0.002 N NaOH, and for the sulfur dioxide it is 0.03 N hydrogen peroxide. The concentration gaseous pollutants in the corresponding absorbent solutions are determined by the so many methods. One is the modified West as well as Gravimetric method, and also the method of measurement of air pollution, that is choosing sampler location and air sampling location that needs to be chosen with additional care depending upon the objective of the measurement campaign, and the altitude of sampling location should be identified depending upon the type of steady region, that is a roadways, whether we are steady we are taking in the industrial area or disposal sites, or we are carrying out in the residential area. Depends upon that we have to check which method is available. Generally, it is kept at a height of about 3 meters to 10 meters from the ground level and sufficiently away from the disturbance of the direct obstacles from the source under consideration. So, the regular monitoring campaign of national ambient air quality measurement that includes the particulate matter typically for 24 hours at least twice a week, making about 104 samples per year. So, for routine sampling to determine the compliance with the National Ambient Air Quality Standards CPCB guidelines have to be considered, and before selection of the sampling location, point and non-point sources of pollution should be analyzed visually, and the monitoring should be done at outside the zone of influence of sources. Tall and large buildings and then trees and other structures extending above the height of the monitor, they may present barriers for the deposition of surfaces for the particulate matter. So, the distance of the sampler to any airflow obstacles like buildings or trees must be more than 2 times the height of the obstacle above the sampler. So, there should be an unrestricted airflow in 3 or 4 quadrants. Certain trees may also be sources of particulate matter in the form of detritus, in the form of pollen grains, or in the form of insect parts. So, these can be avoided by locating samplers by placing them above 20 meters of height from nearby trees. And then after collecting this, finally the results obtained from the experiments are compared with the prescribed standards, that is air quality, national ambient air quality standards, to assess the impacts. So, we can also see how this will minimize the complexity of understanding the impacts of multiple air pollutants. So, air quality index has been formulated for this monitoring the quality of air in major urban centers across the country on a real time basis and enhancing the public awareness for taking mitigatory action. So this air quality index, that is consisting of 5 pollutants, that is a particulate matter, second one is ozone, nitrogen dioxide and carbon dioxide. So the units of measurement in this is normally we can consider as microgram or milligram in case of carbon monoxide per cubic meter. So the air quality index, it has been present and launched for 10 cities. It has been launched in our country: Delhi, Agra, Kanpur, Lucknow, Varanasi, Faridabad, Ahmedabad, Chennai, Bangalore and Hyderabad. So it has been developed by the Central Pollution Control Board in consultation with the expert group that comprising medical, air quality professionals and other stakeholders also. It has also joined the global league of the countries like United States, China, Mexico and France that have implemented almost for the smog alert systems. So there is a sensor network for air quality monitoring is there. Globally, there are several research projects have been exploring the possibility of the collecting the air quality data using the low cost sensor platforms like OpenSense, that is the OpenSense as well as CitySense, normally they will call it as, and they will use the mobile platforms to monitor air pollution levels and its changes in the cities. Every aware is another agency that is the that helps the citizens that how to collect and share and the noise and air pollution data, and similarly that is a CitySense that is empowers people to use low cost air quality platforms in 8 cities across Europe. And also these air pollution sensors can be classified into again 2 groups, that is those groups that measures gas phase species and also those groups that measure particulate matter. So commercially available gas sensors are operated by measuring the either of the electrochemical interaction between the sensing material and the pollutant, that is normally called it as electrochemical or metal oxide technologies, or by the absorption of light at the visible range. So the particulate matter is measured by light scattering method or absorption by using so many algorithms to relate the signals to the particle size and also for the composition. So these individual sensors of course need to be investigated and also integrated into a sensor platform or node. So the sensor node that contains a sensor board, the sensor and the control board, and that integrates all the required electronics, that is a signal conditioning, GPS and communicating ports and data storage. So the number and type of commercially available sensor platforms is increasing at a rapid pace. And the price of individual gas sensors are also ranging from 2,000 to 15,000. So the cost of commercial sensors node that includes also they have sometimes 40,000 or to 4 lakh. So low cost sensor platform also can be used and also plays a significant role and also gives the same authentic information for the air quality monitoring. So the sensor nodes can be deployed for the dense networks, that is a ubiquitous monitoring we can call it as, are mounted on vehicles that facilitating the elaboration of high resolution of air quality maps, the reduced size of the low cost platforms that also allows new research in personal exposure. And also wearable platforms which are also able to consider changes in exposure due to the changes in location and activities that provides new capabilities to evaluate health risk from air pollution. Dear learner, I would like to conclude over here that meteorological factors influencing air quality and then air quality analysis method so far we have studied, and then how it will impact on our adverse on human health adversely. So we have to learn how to live with the pollutants and how to secure ourselves with these air pollutants by taking the possible measurements. Thank you.